Hello everyone, today we're going to be going through some physics unit 1 stuff, especially relating to the kinetic particle model and specific heat capacity. Alright, so what the hell is the kinetic particle model? Well, it states that all matter is made up of particles that are in constant random motion. Okay, so if we have like a container this. So say this is like ice cube or something. It's going to have particles within the ice cube, and because it's a solid, they're not going to be moving very fast. Okay, so they'll be made up of particles, but these particles will be not still. They'll still be moving, but they'll just be moving and more vibrating than actually moving around like you would see in any gas or even liquids. So that's for a solid. They're not really moving very fast. If we take that ice, it melts and it becomes water. So now we're looking at the water part. The water, the particles are going to be moving a little bit faster. Okay. So within that container, these particles will be moving, and then if we evaporate the water, then it turns into a gas, and then the particles are going to be further spread out and moving a lot faster. Okay, so now if we look at the gas form, these particles might be all over the place. Okay, random motion, but they're going to be moving faster, have more kinetic energy, which also often means they're moving faster. Okay, so that is the kinetic particle model summarized really quickly. Now we can start talking about the concept of thermal energy, temperature, kinetic energy, heat, and internal energy as well. So I want you to think of heat and temperature as two very different things. Okay, heat is the energy transfer of thermal energy. Okay, temperature is a measure of the kinetic energy within the system. So here's a quick definitions of all the key terms that you should probably be aware of, because temperature and heat are very different things, and so is kinetic, thermal, and internal energy. They're all quite different. So we look at temperature. Temperature is the average kinetic energy of a particle. And so if we have a higher temperature, it means the particles are moving faster. It means they have more kinetic energy. That's like with gases. If we're looking at the same material, this will have a higher temperature, therefore more kinetic energy compared to a liquid and solid state. And then if we look at the definition of kinetic energy now, it's just the energy of motion when we're looking at a single particle. Okay, so whereas this one, we're looking at the average kinetic energy of all the particles, so the average kinetic energy of particles. Kinetic energy, which is energy of motion, we're looking at single particles. Thermal energy, that is the total kinetic energy of all the particles. Okay, so thermal energy and temperature are quite similar, but thermal energy, we're looking at the total kinetic energy of all particles. Alright, and this will be expressed in joules. Temperature, that will either be expressed in Kelvin or degrees Celsius. Now, internal energy, that is the total microscopic energy. So we're looking at kinetic plus potential energy within a system. So we're not just looking at the kinetic, but also considering the potential. So that's internal energy. And heat is the process. Okay, so it's the energy transfer due to the temperature difference. Now in another video we'll look at the different types of heat transfer, so like conduction, convection and radiation. But just remember, heat is the process, temperature is the measurement, and then we have the different forms of energy that you need to be aware of as well.